Okay, welcome back. We are into the last chapter, actually, last two sections of the semester. So we are into chapter 8, and it's super cool because now we're going to be able to take our triangles and trig equations and everything else we've been doing the whole time for the last 2 months and take the right triangle and finally, sorry, I'm a little bit excited about this, but I love seeing this stuff put into motion. Apply the trig to any triangle, which means any scenario on the planet. Super cool. So this section is called non-right triangles. In other words, any triangle. And it's going to introduce what's called the law of sines. And the objectives, we can kind of go ahead and take a peek at it if you'd like. We're going to use the law of sines. It's something called the law of sines that are right here, which we'll get to in a second. We're going to use a new rule to solve non-right triangles and find the area of these non-right triangles in different scenarios, and also to solve applied problems using what's called the law of sines. So the law of sines is huge, and I'm sorry, I even kind of kick myself sometimes because I was like, oh, hold on for a second, you're getting excited about a math formula. But here it is, the law of sines. Let's just get going. Says that for any triangles with sides A, B, and C, and I'm reading right here, and its respective opposite angles, angle A, B, and C, that you're going to have this new formula here. And really, you don't need the whole thing. But what we'll find ourselves using is something like this. You find sine of an angle and its opposite side is going to equal the sine of a different angle and its opposite side. You're never going to use all three, but what that's saying is you can use these kind of at free will, and it's super cool. So let's go ahead and try a couple of examples. I'm sorry if I'm a little excited about it, but usually this whole semester is built up to these 2 points. And if we can get past 8.1 and 8.2, there's some fun times. So we'll see how far we can go. So first off, there are some cautions. You need to notice if you're going to use this formula here. Let's just talk about what it really means. There's four things: an angle, and the side of the side. So there's an angle, there's an angle, there's a side, there's a side. The law of sines is crazy cool, but you have to know three out of the four. In other words, two angles and a side, two sides and an angle, and so forth. And as we move forward, we'll talk about some of the ramifications of that. But there's some fallout depending on what kind of scenario we have. So the first case, which we'll talk about right now, is when you know one side and two angles, you're going to have one solution. When you have both angles, I don't care if they call it from geometry angle side angle or side angle angle, either one doesn't matter. As long as you know both angles, there's not much to talk about. You just figure out your triangle, and you'll see what I mean. Well, right now. So if they're asking you to solve this triangle here, solving meaning know all the angles and all the sides, that means figure out all the angles on all the sides. But this time there's no 90-degree triangle, no unit circle. We are now beyond those restrictions. And the first thing I should remind you of in geometry, all the angles of a triangle add up to 180. So if you have 50 in one angle and 30 in the other, that's 80. So this angle here already, before I get started, has to be 100. Okay? So that's the first thing. So really all I'm left to do is to find out those two sides of a triangle. Now, if those two sides, really all I need to figure out, you can use the law of sines to do this. Here's what's so cool. Check this out. I can say the sine of an angle I do know, which is 30 degrees, over a side I don't know. In other words, I know this angle here, but I want to figure out that angle there. Well, as long as you know a relationship as far as the sine of 50 degrees over 10, which is here, right, and here, as long as you know that, you can use some algebra and figure things out pretty easily. If I multiply both sides by c, right, and let's say, well, I hate to do this, But there's some quick algebra steps you need to learn to make this a quicker process. If that's sine of 50 degrees times c, and I'll do it out for you this time, divided by 10, then you can multiply by the reciprocal. In other words, in red here, I'm going to multiply, I'm going to erase this because I'm going to hurt for room later. 10 over sine of 50 degrees, and do the same thing, 10 over, gosh, almost ruined that. Apologies. The sine of 50 degrees. But notice what happens when I do that. This 10 goes with this 10. So that 10 goes, sine of 50 goes with the other sine of 50, and I just end up with C equals all of this other stuff. And if you go ahead and make sure you are in degree mode, getting rid of this for the next portion of the problem. If you're in degree mode and you hit enter and all that, pause the video, see what you come up with. Wait. Now in degree mode, you got to make sure that's 10 times sine of 30 degrees. I would hit enter at that point. Don't try to plug in all these parentheses, otherwise you get lost in them. And then hit enter and then divide that answer by sine of 50. You should get something like 6.52. In which case, that's this side here, 6.52. Done. And all you have to do at this point is get the other side, B. Now notice that's a decimal approximation. So if you can avoid using that sign in future calculations, I mean, you can, but then you deal with some round off error. But again, if I wanted to find B, which is here, you could then go, and I'm going to draw pi here, the sine of 110 degree, oops, excuse me for that goof up, the sine of 110 degrees over B. Notice it's always the angle opposite the side that you're interested in, equals, now again, 50 and 10 are kind of staples here, so I'm going to use that again, the sine of 50 degrees, and you can do this multiple ways. There's a zillion ways to do this. Now watch my algebra. My 10 is going to come here, sine of 50 is going to come here, my B is going to come there. It's all algebra, so 10 cross multiplication, sine of 50 degrees equals B. And you could work that out later, but when you're all said and done, B is just going to be 13.054 degrees. Oh, I'm sorry, not degrees. Boy, did I have that wrong. It's length, so it's not going to be in degrees. So 13.054, and you're just done. So if you can figure out all the angles, boom, 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 because you know that all the angles in a triangle are 180, you can use the law of sines to figure out the sides and so forth. The one stipulation is when you're using this formula, you have to know 3 out of the 4. 2 angles and a side, or 2 sides and an angle, which are fine. But over here, this second case, when you know 2 sides and 1 angle, now let me make fun of this for a second. SSA, I always write it as ASS just to make you laugh. It's the same thing. However, you have 3 possible things going on when that occurs. So you're going to get tested for this on the exam, any exam in the future, myself, any other instructor. So let's talk about the 3 ways that can occur. So already, listen, example 1 was this example here, where you know 2 angles and a side. But when you only know 2 sides and an angle, side, S-I-D-E, S-I-D-E. So when you only know 2 sides and you're trying to figure out the other angle, sine and inverse sine, because of the nature of how you find it, presents some problems. Okay? So here's one thing to look at. If you only have one solution, and that's going to be this case, this video might be a little long, but if this is the case that you're messing with, you're going to solve the triangles shown below side-side angle. Notice 12, 9, and the angle of 85 to the nearest tenth. And we're not going to round off to anything else other than the tenth. And if I wanted to figure out the angle, I'm going to start off writing what I do know. I know the sine of 85 degrees, that's here, and its side opposite is 12. And the law of sines, if you want to refresh and go back, I'm only looking at two of the cases. And really it's written out three ways, so it's just trying to say you can pick any side and angle. So I picked one side in the angle that I knew. And let's say I want to figure out, this angle beta here. Then you could say, let's figure out sine of angle beta over 9. Now that's all fine and dandy. I'm going to multiply both sides and get 9 sine of 85 degrees over 12. And again, I'm not trying to mystify you guys, but you should be able to pick up on how to do that at this point. What's the sine of beta? When I crank all that out on the left side, I should get 0.747. I have not rounded yet the sinus of beta. When I do the inverse, I'm going to take in that ratio, and it should give me the angle that represents that ratio. Now here's something to be careful of. That inverse angle is going to be 48.3 degrees if I round. Okay, that's great. 48.3 degrees. So let's see if this is 48.3 degrees. I'm going to put it in there. Now notice when I do this, and I'm going to erase this, but there's this unit circle we've been talking about, 48.3 degrees, which gives you in red this distance here. But you should be comfortable with me saying, hey, you know what? This is 48.3 degrees there. That's a reference angle. And the sine, remember, is always y. It gives me the same distance y. So even though your first answer will give you between here and here, now listen to what I'm saying, your first angle will always be between pi over 2 and minus pi over 2 because of the inverse limitations as far as what your answers can spit out. You've got a first angle here. It might work, it might not. But there's always a secondary angle, its respective angle over here, that if you take 180 minus that, so for instance, 180 degrees minus 48.3 degrees, the angle actually could be. So if you do 180 minus, and here's the thing, if I do that, in other words, this angle here is 100, and I'm going to erase all of this. I wish it could stay in the notes. This angle here is 131.7 degrees. I've done the calculations already. Trust me on this one. So, but that's a possible other angle that could work. So you have to check it. Now, if this is to work, now, and again, this won't be in your finalized notes, so you need to keep watching this. This is called an ambiguous case or just a check to see about this other possibility. Again, remember, you get one angle here, it's 48.3. I'm hoping that works. It looks like an acute angle here, so it probably will work. But I also have to check the other inverse angle because sine, when you do the inverse, there's another possibility of this 131.7. So here's how you check it. You have to see if it works in the realm of triangles and geometry. So what do all the angles of a triangle give you? 180, right? So all three of the angles have to add up to 180. If that were to be your angle, you'd have to subtract off, because you'd still need this other angle here, right? 131.7 minus this angle of 85 degrees. And if you were to do that, you're going to get something like negative 36.7. It just doesn't work. So because the other option doesn't work, we're going to strike it. Get it? Because this, if it were possible, will give you a negative, and I guess it didn't come out that well, a negative angle for here. The whole thing gets tossed out and you don't have to consider it anymore. So in essence, watch all the what is it? Animation and erasing? The erasing, as I make fun of my English language and slur a couple words here on purpose. So what that means is this option cannot happen. And then in the next example, we'll talk about where it can happen. But because that cannot happen, the big thing of this is that this has to be true. Now remember, this only happens when you're finding the angle for the law of cosines. Or sorry, sines. All right? So you just proved that there's nothing else possible. So the only other thing to do here, excuse me, is to find that angle. And if this is 85, 180 minus 85 minus 48.3, excuse me, should equal 46.7. You can check my math later. That's what you got to be careful. Again, you don't care about finding sides. When you use the law of sines, if you're finding an angle, you always have to do a double check for that. Because, like we were mentioning earlier, you either have one solution, two solutions, or no solution. We just did the fact where there's one solution. Get to the other two in a second. So if those are my other two solutions, if those are the other two solutions, all you then have to do is figure out that side A. Now to figure out that side A, well, you can do it a zillion different ways and a zillion different formulas. But again, because you already know 85 and 12, I'll leave this to you. Sine of 85 degrees, 12 is going to equal sine of 46.7 degrees for the sides you don't know. This, if I times both sides by A, listen to how I'm talking. A goes up here. Watch what happens, and I'm going to flip that. A is going to equal the sine of, I haven't even done this, times 12, sine of 85 degrees. You guys can do that on your own, because I don't want to take the time right now to plug that into my calculator. Again, remember you're in degree mode. The big thing was to check that this angle here was legit. Okay, so that's one solution. Like I said, we checked that up here. Let's go ahead and talk about two solutions. This is the hard one. Now, if they're being asked to solve this triangle to the nearest tenth, let's say you know, and you know this angle 35 and this opposite side 6. So remember that the law of sines says the sine of an angle over A equals the sine of an angle over side B. Sorry, the headset cut out. You could start filling stuff in and say the sine of 5 degrees over 6 is going to equal. Now let's try to do this angle right here. Now it's obtuse, meaning according to this picture, it should be bigger than 90 degrees. Let's just suppose. So sine of 35 degrees over 6, which is that side there, is going to equal the sine of, this is the big part of this whole lecture, sine of some angle beta, call this beta, or 8. Now, as soon as I multiply both sides by 8, I'm going to have 8 neatly and as concise as possible. hard for me. And this should be 0.7648 equals ratio. It should spit out the angle beta. I'm doing that, and on your calculator, remember the limitations for inverse sine. I have to be between 90 degrees and minus 90 degrees, and it spits out 49.9. That does not look like something that's less, or excuse me, bigger than 90 degrees. So if you're going to do it that way, that's fine, right? No problem. I'll erase this stuff because I know kind of where I'm headed here. But if that doesn't work, the other option, remember on a unit circle, again, I wish I could leave this part in the notes. If this is 49.9, this has to be 49.92. In other words, the sine, this y side has to be the same for both of them. In other words, there's two angles that's going to give me 0.7648. It's either going to be 49 degrees or it's going to be, well, if that's 49.9 degrees, 180 minus that answer. If I do that up top here, 180 minus 49.9 degrees, should get 130.1 degrees. Now, here's the check. Will it work? No? Check. Let me erase this stuff, my little formula thing I had up here. And this is called the ambiguous case because you don't know which case you have. But your check to see if it works is, hey, if I have 180 degrees, that's all the angles can be in a triangle. If I subtract this, if I had a triangle, and then I also subtract this 35, does it work? In fact, it does work, 14.9 degrees. So that's what you end up having. This ends up having to be 14.9 degrees. This angle here has to be 130.1 degrees. Okay? So you have a solution here that's not the solution that you started out with. Here's the thing. When you have two solutions, one solution is that one angle is this 130.1 degrees. But there's also this other possibility, and I have to apologize for my crude drawing here. If this side of the triangle, which is still 6, lies there and it gets extended, then that would make it possible for this angle here, 49.9 degrees, which is right there. So that's the case that you need to be aware of, that the 6 is either here or here, and if that just swivels, which then makes this angle different, you can figure that out after the fact. You'll also have a triangle that doesn't just hold true for this 130, but if you have a separate triangle in a different color, let's call it green, where you go this way and this way and this way, you can have 49.9, 35, and then this angle here, which you can figure out as well. So all you have to do is 180, and I don't have this figured out already, minus the 35 here, minus 49.9, and excuse me while I try to jam this into my calculator. But what I'm getting is that this green angle here is then 95.1. So in this case, you have two solutions that satisfy the equation. You have an angle of, and I'll use another different color. I'm running out of colors. So this angle is either 49.9 or 130.1 delineated by this triangle or this triangle. But that's the case where you have two solutions. So be careful. That's why it's called an ambiguous case, because you never know. Notice, here's the ambiguous case here, whether you have one solution or we just talked about two solutions. Now the only other case, which is a little bit easier, so every time you get a check, and I would highly recommend you go back and watch this video as far as example 2, where this didn't work and only worked for one solution. Or you come back and look at this one here where there's two solutions. Now check out example 4 where there's no solution. We're kind of giving it away before it even happens. If they say, and I should erase some of this, and this will be the last part of this video, find all possible, excuse me, find all possible triangles with the side length 4 opposite an angle of 50 degrees and a second side length 10. So we can do that. Here's 50 degrees. That's opposite a side of 4. We don't know if it's really going to reach. And then the secondary side is side 10. So if you don't know any of that stuff, what I'm trying to encourage you to explore and try out, and again, these are 3 different solutions. Hint, hint, you're going to get 2 of these on your midterm. You can say the sine of 50 degrees has to be opposite side 4, based on how they're asking you and demanding the whole thing to be set up, equal to be the side of some angle, theta, has to be there, over 10. Now, if I multiply both sides by 10, beautifully at this point, those go, and I end up with sine of alpha, all this other stuff. All this other stuff will be 1.915. Do it on your calculator. Make sure you're in degree mode, as you're in degrees. And then when you try to figure out that actual theta, you have inverse sine of 1.915. If you do that on your calculator, it'll blow it up. And that's pretty much based on the fact that no matter what angle you plug in there, you can't have anything for an output over 1. So what I wrote in my original notes was, nope, can't do it. So there's nothing you can do. So this one is no solution. Okay, so that's the big deal. Again, summary. When you're using the law of sines allows you, if I erase some of this stuff, to now relate, and this is all done through proofs too, and all this other stuff that we've done throughout the semester, as far as identifying and validating formulas and so forth. The law of sines allows you to open up your world to non-right triangles. When you do that, if you're opening yourself up to non-right triangles, you have a couple scenarios. Now, for example 1 here, again, I'm just summarizing as I'm cleaning up my notes. You can have one side and 2 angles known. When you do, piece of cake. All you have to do is know the relationship. And notice this is the angle 30 opposite this side. And then another angle 50 degrees opposite a side, something that you do know. You can plug in 3 things that you know and then solve for the 4th thing. Piece of cake, not a problem. However, caution here. Okay, so for number 2, you want huge caution in the fact that when you only know 2 sides and an angle, side angle, that there are 3 possibilities. You can have 1 solution, 2 solutions, or no solutions, and we've gone over those. Example 2, 1 solution. We knew it was 1 solution because the other solution was not possible. Example 3, where there were 2 solutions, as I'm kind of scrolling down here. Remember, so you had 2 solutions of 49.9 and, oh gosh, 130 point something, which was up here. And our third case was when example 4, there was no solutions. It took me a long time to understand the difference between those three options. But every time what you're doing is you're pretty much searching if you can have this secondary triangle like you had, and I don't like you had here. So I'm trying to just give you some time to kind of look at it. There's my secondary triangle, which I created because the option could occur. Now, the option can only occur when you subtract all these angles. Remember, 180 minus 35 minus 49.9 still left me with some number here, so I could have an angle. Now, or up here is where I did my check actually. So 180 minus 30.1, which is this angle, 35, which was this other angle, which gave me that angle to begin with. So when you can have two triangles, you need to identify that and be able to run with it. As if that's not enough, there are times where it won't be able to happen at all. Okay, so that's all I got for now. Big lesson there. And if you need questions, get a hold of me. Take care.